All right. So look, draw a grid, X, Y, and draw the Y equals X. Because as you all know from your algebra days, if I have a point, A comma B, and I do the inverse of it, that point turns to B comma A. I'm going to put on my mask. All right, so now I'm going to draw two graphs. I'm going to draw a graph F and a graph G. And the graph G is going to be the inverse of F. I'm going to call that graph F. I'm going to call this graph G. And if this over here is point A comma B, then this point right here is B comma A. So what did I just say? I said that G is the inverse of F. Is anyone confused at the moment? Okay. So let's say I want the derivative at B. I want to know what that value is going to be. So let's think about it for a little bit, guys. So here's my tangent. It almost looks parallel to the y equals x there, but it's not. Well, now it is going to look parallel because, damn it. Sorry, did I say a bad word? I did. I'm going to have to edit it. I didn't want it to look parallel, guys. That's besides the point. Okay, good. Yeah, if yours don't look parallel, that's even better. So don't make it look parallel. Make it look skewed. And the two lines should intersect right at the y equals x. But anyways, it doesn't matter. You know what? I'm going to draw this again. Okay, fine, that's fine. So let's say I want the slope at B. Obviously here, the way I drew the tangent lines, it looks like they're going to be the same value. But let's assume that they're not. The slope at B, well, think about it, guys. When I'm talking about slopes, slope is the change in y over the change in x. But when I do the inverse, because you're switching your x and y, the inverse slope is just the reciprocal, change in x over change in y. Do you guys agree? Do you guys agree? The virtual class.
Yes.
Yes.
Okay, so here's the hard part. If I want my slope for G at B, I have to take the reciprocal of F at A. Why? That's the hard part. Why? Because they're inverses, yes, but not everyone sees that. Guys, this point right here is at AB. This point right here is at BA. It's practically the same point, but they're inverses of each other. So if I have this slope, F prime of A, look, notice that I wrote F prime of A. If I have that slope of F prime of A, and I want to know the slope, but not of F, of G at B, well, then all I do is take the reciprocal of whatever the derivative was at A. Yes, take a couple seconds to group those thoughts, guys. Take it all in. Look what we just said. And it has to do with this. The slope of the original is y divided by x, change in y divided by change in x. The slope of the reciprocal, the slope of the inverse is just a reciprocal of that. Change in x divided by change in y. 1 over whatever means reciprocal. So think about it. If I have f prime a and I want the slope at b, g prime b is equal to the reciprocal of f prime A. Are we okay with that? All right. So having said that, okay, so what did I write here? So calculus of all, think about it. What if we want the derivative of an inverse function at a specific point, but we only have the original function, and it will take too much algebraic manipulation to find the inverse function. So g prime of B is equal to 1 over f prime of A. That's it. That's the big deal. Yes, but I don't have, yes, if A and B are, yes. It's just that I don't have an A on blue, that's why. But yes, I know what you're trying to say.
Oh, so then what if, okay, f prime of A is equal to 1 over g prime of B?
Yes, it is equal to that. Cool. All right, let's see if we learned. Take that knowledge that we just did. I'll give you guys 2 minutes. And 3 minutes. It doesn't take that 2 minutes. 28, just 28. Take that knowledge and see if you can do the hardest question on 2008 AP exam. And please participate, guys, and answer a question. Only 2 of you have answered. Have you guys answered, guys? All right. Here we go, guys. This is the hardest question on the differential AP calculus exam. Only 14% got it right. All right, here we go, guys. Here's the key. G and F are inverses. They want the derivative at 3. So notice that's an X value on your G graph, the inverse graph. So that means I'm going to be paying attention to this one right here. Does everyone know why I'm paying attention to that one? Because that coordinate was 6, 3. Now remember what we just said. We just said if we want G prime of 3, that has to be the reciprocal of F prime of 6. Because that was your B value. That's this right here, guys. See, look, that was your B value, 6. So now it's G prime of 6 there. Do you guys see that? Okay. So now that we know that, so then we're looking like, all right, so what's F prime of 6? And I see that F prime of 6 is -2. So the reciprocal of -2 is -½ And you can see now, look, even the 5s are having issues. Only 38% of the 5s got this one right, and 13% of the 4s. If you get these wrong, it's okay. You'll still get your 5. But if you want to assure your 5, get these correct. And these are hard, guys. You're just going to have to really understand the concepts. And there it is for you. I put it right there. I tried to discuss it as much as I could. If you go to page 3, you can see this is what I tried to do. I tried to make slopes that were not parallel. You can see right there, we said the same thing. Now we're going to do an informal proof. So who knows, maybe we should have come here first and then got a question, excuse me, question 28. We're going to do an informal proof for y equals inverse sine x. You guys ready? So here we go, guys. And now these aren't that bad. They don't come out all the time in the AP exam, but they do come out. Arc sine and arc tan are the two that come out the most, and then I would say arc cosine is the third one. So we don't know how to take that derivative, so I'm just going to write it like this then. Sine y equals x. That's what it means. That's what this means. We know how to take this derivative. So here we go. Sorry, I see a mosquito. Okay, so here we go. What's the derivative of sine y? What? Sine y? The derivative of sine y is cosine y. Sorry, I thought I heard you say sine y. Cosine y dy dx, sorry miss, equals 1. Now what I'm going to do, what am I going to do now? Dy dx equals 1 over cosine y. But I don't want to have dy dx, I don't want to have my derivative in terms of a y value. I want to have it in terms of x. So then I come over here and I do side note. And I'm going to go cosine squared y plus sine squared y equals 1. Yes or no? So then I'm going to isolate the cosine y. You can already see what I'm doing. Cosine squared y equals 1 minus sine squared y. So cosine y equals the square root of 1 minus sine squared y. And to make it easier for us, I'm going to say 1 minus sine y with a square on it. So I'm going to come back, and I'm going to substitute that in. Oops. And I love it, because look what I have up here. What does sine y equal? X. So here's my formula. This is not a formal proof. This is an informal proof. I would have to state a lot of rules here. And there it is. That's your derivative for arc sine of y. I mean, arc sine of x. So with chain rule, let's see, d dx of arc sine of u, where u is differentiable with respect to x, you're going to say 1 over 1 minus u squared square root du dx. We're okay, guys? Okay. All right, guys. So here we go. Example 1. All we're doing is applying the formula. Nothing fancy, just mechanics. So I'm going to put it up here so you guys can see it. d dx of arc sine of u equals 1 over square root of 1 minus u squared du dx. So 1 over square root 1 minus x squared squared times 2x. 2x over square root of 1 minus x to the 4th. If it's a free response question, you can leave it alone like that. On UH, they're going to be doing a lot of algebra. Sorry, guys. I can see that my internet is going in and out. It's saying that it's unstable. So I apologize, virtual class. It's probably going to be like that the whole day. Are we going to derive all of them from scratch? No. Here's the list. Let's fix them all with chain rule, guys. We already know 19. Do you guys want me to write 19 again anyways? With chain rule? D dx arc sine of u, and maybe put the parenthesis in the u there, equals 1 over square root of 1 minus u squared du dx. Here's number 20. The only difference between arc sine and arc cosine, take a guess. It starts with a negative. It starts with a c. Remember that every time, everything that starts with a c for derivative is going to have a negative in the front. It's the same as arc sine, but with a negative in the front. I don't have enough room, so I tried to do it left to right, but maybe I'm regretting it now. D dx of arc tan of u equals 1 over 1 plus u squared du dx. Write them all, guys. I'm just going to do up to there. Which one are the ones that come out the most? Yeah, the top two. Arc sine, I'm going to call this one number 1. And it's actually not arc cosine, but arc tan. I'm going to call that one number 2. The one that comes out number 3, I would say arc cosine. And then I would say arc cotangent is 4. And then I would say arc secant is 5. And then the least, 6. So those are the rankings. Do you have to memorize them all? No. If you know arc sine, you know arc cosine. The only difference is that arc cosine is negative. So you already know it. See how simple it is? If you know arc tan, then you know arc cotan. What's the difference between arc tan and arc cotan, the derivative? Negative. The derivative for arc cotan is negative. See? So you don't have to memorize a lot. Which, if you only bother memorizing 2, the only 2 that I would bother memorizing is number 1 and number 2. And then you'll figure out 3 and 4 just from those 2. And then I wouldn't even bother with the arc secant and arc cosecant. Cool or not cool? Okay. So let's see if we can, now that you know that, do I tell you guys to put, let's see if you guys can do go back to the front and see if you can do number 26. Only 25% of the people got this one correct, guys. So give this one a shot. Number 26, take 2 minutes. I think it's that one. It looks like it is that one. And it's okay if we're wrong, miss, because this is how we learn. No one's going to judge you. Yeah, kind of, what'd you get? Oh. All right, guys, here we go. It wants to know the slope of the tangent line of this function at this point. And you have no calculator because it's number 26. So you just got to know what the derivative of arc tan is. What's the derivative of arc tan? 1 over, oh man. Yeah, 1 plus u squared. So my u is 4x. So 4x, close it, put a square on it. Am I done? Times 4. And now all I do is plug in 1/4. Y prime at 1/4 equals, let's see, 4 over 4 times 1/4 is 1. 1 squared is 1. 1 plus 1 is 2. So 4 divided by 2 is 2. And you can see why these are the hardest questions in there, guys. Example 2. A particle moves along the x-axis of its position at any time t greater than 0 is equal to that. What is the velocity of the particle at t equals 16? Okay, I'm going to rewrite it. X of t equals arctan. You can either spell it out or you can write it out. So there it is. I rewrote it just to help me out. V of t. I guess I didn't need to rewrite it. The derivative of arctan. 1 plus square root of t squared times, no, this will help me right here. Chain rule, 1/2 t to the negative 1/2. So rewriting this, 1 over 1 plus t when I square the square root of t. And I'm going to have a square root of t next to it. And a 2 in the bottom here as well. I could have put them both together, guys. I didn't. I'm going to plug in 16. 1 over 2 times 17, square root of 16. So you get 1 over 2 times 17 times 4. Let's see. I'm going to get no calculator. 15, 30, 34, 34 times 4, 30, 60, 90, 120, 4, 8, 12, 16, 120, 130. Is it 136? I could be wrong. You guys let me know. That's right. Example 3. I don't bother memorizing this one, guys. I think I know it. I don't bother memorizing. Let me see. I might get it wrong. We'll see. Let's see. This is 1 over absolute value, so 5x to the 4 square root. I think this one is 5x to the 4 squared minus 1 times 20x cubed. If you get these wrong, I'd be okay with it. I wouldn't be like 100% okay with it, but I'd be like all right with it because they rarely come out. 5 goes into 20 4 times. And then all of those x's are canceled. So I have 1x in the bottom. And that's going to be 25x to the 8 minus 1. Now, when you take the UH quiz, it's going to be doing a lot of algebra. And they are not going to leave it like that. So I'll probably be doing a lot of algebra review tomorrow to see if we can figure out algebra stuff first. So try not to be late tomorrow, guys. Well, if you're good with algebra, don't worry about it. You can be late. Don't worry. I wasn't late. Okay. How do we feel? Do we feel okay? One more. All right. Cotangent x,
Can you
guys.
repeat what you said?
Okay, say it again.
Can you repeat what you said?
That we're going to be doing a lot of algebra tomorrow. So just if you feel like you're really good at algebra, then I guess no, we've got to make it mandatory for everyone. Show up. I was gonna exempt you guys from coming if you felt good with algebra, but no, just show up. Be there. Be in class. Or should I make it optional for those people that are good with algebra? Okay. Yeah, come in, because we're going to be doing a lot of algebra, manipulation with algebra, guys. All right, on this, we got to know a little bit, not that much, just a little bit. Our principal branch for cotangent x looks like this. Or does it look the other way around? Pi 0 for arc cotangent. Yeah, so the domain for cotangent is between 0 and pi. So that means when I look at arc cotangent, my output, the y value, the y value has to be between there. So on the unit circle, if I only look between 0 and pi, just between 0 and pi, where is cotangent going to be -1? At what radian? Not everyone at the same time, guys. At 3 pi over 4. So that's my point. Travis, what are you doing? I don't know anything that you're doing right now. I'm trying to find a tangent line, and to find a tangent line, I need two things. What and what? Point and slope. Are you guys okay today, guys? Or is today just not a good day? Not a good day. All right, I already have my point. Now I need my tangent slope. So how do I find it? I take a what? I take that's the letter D.
The derivative.
I take a derivative. The derivative of arc cotangent is the same as the derivative of arctangent. The only difference is that I have a what in the front? A negative. 1 over 1 plus x squared. They're being nice to me because they didn't make it, I don't have to do any chain rule on this. So y prime of -1, negative on the outside, 1 over 1 plus 1, so -½ Travis, why is it a positive 1 on the bottom? Negative squared turns to a positive. So there it is. So now I can draw my tangent line or graph my tangent line. Y minus 3 pi over 4 equals a -½ x plus 1. And I'm actually curious to see how this looks like. So I'm gonna graph it, and I want to see it. I want to graph it, and I want to see it. Watch me draw. Watch me have drawn arc cotangent wrong. Oh man, that would really suck. I'm trying to be the Michael Jordan of math teachers, and I can't even draw a correct arc cotangent. Desmos. You guys can't see it because I'm not sharing it. I'm sorry. I just realized that. There you go. So first, I'm going to draw y equals arc cotangent. So y equals function arc cotangent x. Hopefully, it'll give me the principal branch. Yes, we're good. All right. Next, I want to put a point in there. The point was -1, comma 3 pi over 4. Boom, there it is, -1, comma 3 pi over 4. And let's go ahead and look at that tangent line. Let's see if we graphed it right. Y minus 3 pi over 4 equals -½ move to the right, x minus, nope, x plus. Yep, that definitely 100% looks like a tangent line. And math is beautiful again, and the world, everything's okay with the world, and I am at peace, and I am happy that this line looks beautiful. Does it look beautiful to you guys? All right, so we're good. Did you guys get number 1?
Yes, I was just able to get it.
All right, let's see. Did it require a lot of algebra? Probably not. Not really.
I don't think so.
All right, let's see. What rule do I got to use for number 1? Starts with letter Q. Yep, quotient rule. Hey, I thought you weren't going to listen to this. Godinez is so funny, guys. All right, quotient rule. What do I do first? Yeah, low-D high, so bottom times root of the top. What's the root of arc 10? Times minus or plus? Minus low D high minus high D low. All over low low or low squared. So get up to there. If you got up to there, you're winning. So now I'm going to go ahead and do some algebra here. I'm just going to simplify this right here that I got. So let's see, we have 5x over 1 plus 25x squared minus arctan of 5x. And all this is over x squared. And when I look at what they don't have that. So I need to get a common denominator in the numerator, if that makes sense. So I'm going to multiply the arctan of 5x by 1 plus 25x squared over 1 plus 25x squared. So that looks to be the magic or the key. So when you do that, you're going to get, let's see, 5x over 1 plus 25x squared minus, and I guess I'll write it next to it in a little bit. We'll distribute it. There we go. So now I have a common denominator in the numerator, if that makes sense. So I can just do keep, change, flip, or bring the x squared up. So here we go. So now I'm going to write 5x, and then I'm going to distribute this like so. So don't forget the negative there, minus arctan of 5x minus 25x squared arctan of 5x all over x squared, parenthesis, 1 plus 25x squared. Don't distribute that, leave it alone. And I believe that's the answer. They just rewrote it a little different. So let's rewrite it the way they have it. Put this one first. So negative 25x squared arctan of 5x minus arctan of 5x plus 5x all over, and I guess if I wanted to look like the key or the solution, and there it is, and I think I got it looking like it.
Chav,
Yes, ma'am.
Mari says her computer crashed, so she's trying to get back on.
Okay. I'll upload this so she can watch the YouTube video. You guys ready for number 2? Were you guys able to get it? Did you get it?
Oh, yes.
All right. All right. So the crowd here says that they got it, guys. That makes me happy. Real quick, square root of 3 minus 2x squared. That's the same thing as 3 minus 2x squared to the half. And here we go. So I'm going to write dy dx equals, and then the derivative of arc sine is 1 over square root of 1 minus the square root of 3 minus 2x squared squared times, now I got to take the derivative of that on the inside there. So it's going to be 1/2 3 minus 2x squared to the negative 1/2 times negative 4x. It's chain rule. So hopefully no one got confused there. And now it's just gonna, I'm just gonna multiply stuff out. I see a half and I see a negative 4, so that's gonna turn to a 2. So here's what I now have. I have a negative 2x in the front. I see a negative exponent here, so I'm gonna have square root, I guess let me do the first one here. 1 minus, and then when I square that, that's gonna be 3 minus 2x squared. And then I'm gonna have square root again of 3 minus 2x squared. Okay, so now doing a little bit of algebra, I'm going to distribute this negative. You're going to have negative 2x over square root 1 minus 3 plus 2x squared, square root 3 minus 2x squared. I don't see any issues. I think we're still good. And you probably don't need this many steps. You can probably do it in less steps. Square root of 2x squared minus 2, square root of 3 minus 2x squared. And because I can use, the both in the bottom have square roots on them, I can just use one radical or one square root. And I can just go negative 2x, one giant square root, 2x squared minus 2, 3 minus 2x squared. And I believe that's the answer. Yay, another happy one. Are we cool so far, guys? Uh-oh, here it comes. Did you guys finish this one? Just started it? You got it, right? You got it? Stopped at this one. All right, this one here is going to require some algebra. I don't think it's extreme algebra. It's just a intermediate algebra maybe. So here we go. There's two terms, or there's two things going on. You got something over something and then minus arc sine. So understand that we're gonna have to do the derivative here, obviously, right? Because that's what we're doing. So here we go. dy dx, and you got to start off with the quotient rule for this guy right here. So it's bottom times derivative of the top. So bottom, let's see, square root of 64 minus x squared times root of the top, 1, minus top times root of the bottom. So here we go. I'm going to go slow. That's a square root of 64 minus x squared. Bring the half to the front. Leave the inside alone. Raise it to the power negative half. I'm not done yet. Times the derivative of the inside. Is everyone okay with that statement? The bottom times root of the top minus top times root of the bottom.
It's not a half, right?
What?
It's the 3 over 2 in front of the 64 minus x squared.
That's a half. It's a half.
Why is it a half?
Because it's square root.
Oh, okay, never mind.
Oh, talking about the derivative. The derivative is a 3/2, but I don't have a 3/2 yet.
Never mind, I was looking at the wrong.
Okay, sorry, miss. Bottom times root of the top minus top times root of the bottom, all over bottom squared. So it's going to be 64 minus x squared. I think I got it. I haven't finished it yet. And then I got to still do this part. So here we go. Minus 1 over square root of 1 minus x over 8 squared times 1/8. Is everyone happy so far? Okay. So now I'm gonna do some. I'm not gonna do any transformations yet. I'm just gonna get everything to look nice and pretty. So let's see if we can do that. Square root of 64 minus x squared. Negative times the negative is a positive, so I see plus. If you're wondering what am I talking about, I'm talking about that. I see a half and I see a 2, so those go away. So I see, what do I see? X squared over the square root of 64 minus x squared. All this is still over 64 minus x squared. And let's see if I can do this one here. 1 over 8 square root. I'll do it in 2 steps. 1 minus x squared over 64. So get up to there. We got plenty of white space, so we can continue to take up some space. All right, so on the left term, by left term I mean all this here in blue. On the left-hand side, what I'm going to do is I'm going to multiply this one here by square root of 64 minus x squared over square root of 64 minus x squared. So I'm going to do that. I'm going to do it right here on the side. When I multiply the two square roots, the square roots go away. So here's what I'm going to have. So I have dy dx equals 64 minus x squared over square root of 64 minus x squared plus x squared over square root of 64 minus x squared. I could have put them together if I wanted to, guys, but I'm trying to show as many steps as I can for you guys. And on the right term, and by right term I mean this one, I'm going to go ahead and write it like this. That one I'm going to turn to 64 minus x squared over 64. Can I do that? Does everyone know what I did there, guys? Tiff, you know what I did? Yeah. What's the square root of 64? So I'm going to take it out, and there it is. What's 8? Well, 8 over 8 is just 1, right? So they cancel each other out. So look what I now have, guys. So let's see, dy dx. I'm going to put these two together. So let's see, 64 minus x squared plus x squared. These are going to zero out. And I'm going to bring, okay, so here's what I have. Let's see if it makes sense to you guys. 64, and then square root of 64 minus x squared, 64 minus x squared. That's all this right here. Minus 1 over square root of 64 minus x squared. I was going to combine them, guys, but I didn't want to lose you guys. This is 1, and this is the same thing as having a half. Everything on the inside is the same, so I can just put them together, and that's 3 halves. So that's where they got the 3 halves. We're still not done, though, because we don't have our answer. So here's what we're going to do. How much more height space do I have? Oh, I got plenty. I'm going to multiply this one on the right by, let's see, I have a half, so I need a whole. So I'm going to multiply it by 64 minus x squared over 64 minus x squared. So finally, here's what we get. dy dx, 64 over 64 minus x squared to the 3 halves, minus 64, distribute the negative, plus x squared. No, you know what? I'm going to leave it as minus x squared, and I'll distribute the negative in a little bit. And then yes, I'm trying to get common denominator. Virtual class, are you guys following along, or are we lost?
We're good.
Okay. Bless you, salud. How do you say it in French? Oui. Okay. dy dx. My denominators are now the same. I'm going to distribute that negative. The 64s zero out. That negative x squared turns to a positive. And now I have x squared over 64 minus x squared to the 3 halves. Is that what they have? You scared me, man. Why did you say no? Oh, you just want me to suffer. All right, this one's the easiest one because it doesn't really have a lot of manipulation. So it looks hard, but it's not really. So let's see, let's go right into it. So the derivative of rectangle. So dy dx equals 1 over 1 plus u squared, where u is the x plus 6, times 1, because the derivative of x is just 1. And I mean, you don't even have to show that, right? And then we're gonna expand this part right there. So dy dx equals 1 over 1 plus x times x is x squared. X times 6 is 6x, but I'm gonna have 2 of those, so 12x. And then 6 times 6 is 36. And then you can just drop the parentheses, 1 over, and then write x squared plus 12x plus 37. So there it is. We have a whole bunch of white space that we did not use because we didn't do any manipulation. We just went right into it. So this one is the easiest one from all of them. We're okay so far? All right, now we get to this one. I'm not saying this is the hardest. No, I wouldn't call it the hardest. It just has a lot of algebra, and if you don't recognize it, you're just going to be looking at it. So it's really all about the algebra. All right, so again, we have 2 terms, and what I mean by terms, maybe some people out there are going to be hating because like, no, that's not 2 terms. What I mean by terms is I have 1 right here, and here's something else, like a whole bunch of stuff together. And I know terms are usually defined for like a polynomial. 5x squared is a term plus 3x squared. So don't come hating on me, you 2 people. Give me a thumbs up, I hope, hopefully. All right, here we go. So I'm just going to take the derivative. I have 2 little things. I have a plus in the middle, so I'm going to call that a term and another term. So here we go. dy dx equals, I'm taking the derivative. That's a radical. So I'm going to have a half in the front. Leave the inside alone. 81 minus x squared to the negative 1/2. That's a common mistake. A lot of people miss the negative half. I'm not done. Chain rule. Times what? Times negative 2x. We're done with that first term. I put plus. You can either put 9 there or you can put it in the top of your arc sine. It does not matter. The derivative of arc sine, 1 over square root 1 minus x over 9. Put the square on it, times the derivative of x over 9 is 1/9. And it looks like we're done. And now we just got to do algebra. And as you can see, nowhere does it look like you're going to get square root of 9 minus x over 9 plus x. So you're going to have to do some manipulation. And relax, we got you. That 9 cancels out with that 1/9. And so let's fix it up. Let's fix it up first. I see that half cancels out negative 2. I still have a negative, so let's keep that in the top there. So dy dx is going to be equal to a negative x over square root of 81 minus x squared. Let's see, plus 1 over square root of 1 minus x squared over 81. And that's inside the square root there. So now you're here and you're thinking, okay, how am I going to make it look like that? Well, first, the only feasible step that feels natural right here is to do a common denominator to make sure that they're both the same. So before we can get to that, guys, let's make this guy, it is possible to make this one here that I'm circling look like that. So how do we make it look like that? Like this. I'm going to put this on the side, guys. Like this. Square root 81 minus x squared over 81. So here we go. Again, dy dx equals negative x square root 81 minus x squared plus 1 over, the square root of 81 is 9, but remember that's on the bottom there. So put 1/9 square root of 81 minus x squared. Square root of 81. It's in the bottom of the bottom. The denominator of the denominator. From right here.
Wait, where did you get 1/9?
Okay. I'll explain it again, guys. From this guy. So the square root of 81 minus x squared over 81 is square root of 81 minus x squared over 9. Right? And it's still in the bottom. So I can say like 1/9 square root of 81 minus x squared. Yes. I was gonna do it, but everyone was gonna tell me, where'd the 9 come from? How many 1/9 can I fit into 1? Or you can do keep, change, flip, or you just see it. It's 9, guys. If you ever see 1 divided by 1/8, it's 8. 1 divided by 1/7, it's 7. 1 divided by 1/5, it's 5. You guys knew that, right? Of course you guys did. 81 minus x squared plus 9. Hallelujah. Well, I think I can, yeah, that's not going against the man or the woman upstairs, because we don't know. I don't think the God has a gender. The power upstairs. All right, from there I can combine them. Now what? Am I just going to be staring at that all night long? I don't know what to do. So you're just going to look at it and be like, I'm done. I don't know. Guys, don't say that. Yeah, you do. You took algebra. What is the 81 minus x squared? Oh, perfect. It's a what? It is. It's a difference of squares, guys. So now look what I'm going to do. I'm going to go ahead, since I already see how they have it. They have a 9 minus x. I'm going to rewrite the numerator as 9 minus x instead of negative x plus 9. 9 minus x. The bottom is the difference of squares. That is 9 minus x, 9 plus x. So get up to there, and then we'll talk. Hopefully you had a really good algebra 1 and algebra 2 teacher who told you about the laws of exponents. These expressions, 9 minus x and 9 plus x, are inside the square root or the radicand. So I can rewrite this using my laws of exponents as 9 minus x to the half, 9 plus x to the half. OMG, look at that. That's a whole one right there. What's going to happen? How many can I cancel? No, I can't cancel a whole one, but I can cancel half of what term, of what factor? 9 minus x. So the factor 9 minus x, I can cancel half of it. So you no longer have a 1, you have a half left. So now, and then I guess I'll do it in 2 steps. You don't need to do it in 2 steps, you can just do it in 1, but I'll show it everything. I'll show it all. So I have 9 minus x to the half here, and I have 9 plus x to the half here. Half is the same thing as square root. 9 minus x square root, 9 plus x square root. If you have both factors with the same exponent, you can just put a giant parenthesis on the whole thing, or you can make a giant square root on the whole thing. Giant square root, 9 minus x, 9 plus x. Did you guys enjoy this question, guys? Who said no? Man, come on, Tip. I just put so many hours. Okay, I'll stop. All right, guys, let's come back.